let's get on with some introductions. Let's start off with you. And, I had a little bit of an introduction. I met you a few days ago, but let's find out a little about you and where you came from and why you're here and where you're going and all that kind of stuff. Murray, let's start with you. I mean, you guys have probably all heard this, but let me hear it again.
I've got a company called, Murray, probably, of course. I've got a company called Focus 360, which specialises in design and building virtual tours for commercial businesses. Some of the clients being major hotels in Christchurch, like the George, Commodore, the Air Force Museum, Nissan Motors.
Fantastic.
And the Department of Conservation St James Cycle Trail. I'm looking to further push the business into what we were just talking about a moment ago. A client called Corncastle Homes is wanting 3D realities created before the home is actually built, so they can show to clients. And I'm also looking to gigapixel images. I'm actually seeing the Department of Conservation this afternoon.
Fantastic. Wow. Now, how long have you been doing this?
The process to develop virtual tours was about enough to get up to commercial format. And that was when it was only Flash. About 4 years in total, about 5 years in total, and about 3 years in business.
And what did you do before that?
High school teacher.
Oh, really?
That was in another life.
What did you teach in high school?
Physics, IT, chemistry, electronics.
And where did you do that?
All around the place in Rarotonga.
Wow, really? Fantastic. Neato.
Yeah, North Island and South Island, Christchurch.
So your company is doing pretty well then. It's
yeah. Now it's specialising in more products.
When
I'm not there, I just subcontract. I've got a brilliant photographer who's probably better than me, but I don't like to tell him that. It's my son. And
that's your son.
Yeah.
Yeah. You don't want to tell your son.
He's here doing biochem.
Oh wow. Okay.
Just can't carpool all the moment because lectures start at different times of the day. It's another thing. Part-time job too, but that's not something. So it's and I'm doing it. Coming here to acquire more skills really, and more knowledge, and make contacts and network.
Do you have any hobbies? Do you have time for hobbies, or this is your hobby?
This is my hobby.
That's good. Yeah.
Love the photography. And
yeah.
I've just built a website for St John Ambulance. A volunteer roster system. Just got it running last week.
Very good.
Very late. Got it running. So it's actually a donation to them. The service they provide New Zealand. 6,000 volunteers and 900 permanent staff. So they penetrate New Zealand's community. So I call it a very good marketing exercise.
Yeah, they get around.
Yeah.
Yeah. Well, Jonathan, I know a little bit about Jonathan, but I don't know how much these guys know about you. Have you introduced yourself completely to them?
Probably. I started off at the HITLab AU, the etc. And then did my undergraduate, and then when I got to my third year, I had to do a year project. So we did a world play, which was the idea of creating 3D within 3D, which Tom sort of led and guided us along the way and shared with us his knowledge. So that got really successful. And we got actually the ABC radio around Australia. They went onto the news. So we got 15 seconds of fame on national channel as television, and then we got into newspapers and so on. So I did interviews with a few other things. That was pretty cool. And then Tom mentioned about HITLab New Zealand and said, come here. So,
did I say it that way? You had to come here? No choice.
So I came here and based on everything I've seen, and you guys it seems to be a pretty good move, so hoping to learn. And in my spare time, I have a thirst for knowledge, I guess. And I learned silversmithing before I came here. I did leather making. Started up a company, or I was tutoring at the HITLab NZ in the first year students, and then they came to me and asked they're really bored during the summer. They want to do a summer project. So I set up a online community called Fantasy to Reality, which is based along the lines that Tom wanted to do this virtual world society. We'll talk about that later. So I set up the sort of the smaller version. And what I did was I went around to businesses and touched base with a lot of different people to try and see if I could start creating a development team from the first years early on, so that by the time they graduate, they are actually a fully made development team. And I've been somewhat successful in that. And the Director of Human Life Sciences just recently took up the position and was interested in working with HITLab students. So over the course of 3 months, we did some applications with the Connect doing rehab therapy. And he's taking those to the hospital now, and he's pretty confident now with students because he was worried about the skill sets, but after seeing what they can do and where they're going, and after only first years and having another 2 years to build on top of the HITLab, he's really confident in sort of trying to push them along and do more projects so that when they get out, they can start working there. And then I have my own game company.
And you've officially launched your game?
Oh,
Okay.
I got sidetracked, yeah. I was talking with well, that's another thing. So I do YouTube tutorials because I get asked. And yesterday I got contacted about a couple of weeks ago by 2 different people. One group from Silicon Valley in the USA, and I had a meeting with them yesterday. And then another group from the University of Istanbul. And both of them want to do augmented reality applications. So the one from Silicon Valley had this application they wanted to make, which is getting back in touch with nature. So I spent over an hour talking with them different solutions and what to do and trying to figure out. So they want to know if I'll be a paid consultant to work with them. So I said, sure, why not? And then, I don't know, if I see something, I just send an email. I have contacts in Mexico and AI, and I go and university in Austria who will just email and say, hey, can you help me out? And he does Connect programming, coding for you. So I'm amazed by if you just send an email with the contacts and results.
Yeah. Yeah.
That's a bit about me.
Okay, Robin, what about you? You're from Nelson.
Yep.
Yep. Tell us about you.
I graduated here at Canterbury the year before last.
Okay. In
Did honours last year actually, and now I'm doing masters.
in computing?
Yep.
Or in, okay. Mm-hmm.
Yep. And I came here because when I did the group project, the most enjoyable thing for me was doing the HCI aspect. We were doing an Android app.
Mm-hmm. So did you work with Andy Coburn? Any?
Yeah.
Mm-hmm.
He took the 3rd year class.
Okay. Okay. Now in your honors,
Computer vision.
okay, with Richard Green?
Yep.
Yeah. Okay. Very good. What are your hobbies?
I like making music, but a more related hobby to COS would be working on a marine biology kind of game where I was thinking like what senses an octopus, like say an octopus, they have like lots more senses than we do. I'm just wondering how to present that to you.
Wow. To a human user.
Yeah.
Wow. That's
They
interesting.
can sense polarization.
Oh, yeah.
I don't know what that is, but I can think of ways to present it to
Fascinating. Fascinating. There's an area called cross-modal representation of information where you're sensing it in one domain, you're trying to represent it in another domain. I mean, we did some of this for rehabilitation, where you can now see sound or you can hear faces, things like that. But what you're doing is going far beyond that, sounds like. Yeah, fascinating. Yeah.
Still on the drawing board stage, though.
Yeah, yeah. Great. Fantastic. And how about you, Moore?
I'm originally from Nigeria.
Mm-hmm.
Came here in 2009 to my undergraduate degree at Lincoln University.
Lincoln. Mm-hmm.
After graduating, I started working with a company called Orion Health.
Mm-hmm.
Yeah, as a software engineer, and I've been working there for the past 2 years. And we had an innovation week where we had to go to the CDHB, the Canterbury Christchurch Hospital.
Mm-hmm.
And while we were there, we were meeting with different doctors, clinicians, and nurses, and talking with them and seeing how they use our product. And in the process of doing that, I sort of realized that the way I thought they used the product wasn't the way they actually use it, and like the experience they have a lot of the time is very bad and horrible. So Mark went to Epic Building
Mm-hmm.
in the city to give a talk on Google Glass. So I went to that, and he was talking about like the Google Glass, and I was interested in that, and I had my company interested, and we got the glass for a week, and we did some programming, and after then we came over here and had a talk with him, and I saw what the HITLab does, and I thought this is what I want. So
Very good.
my company decided that they would allow me to go and do my master's.
And they're going to support you while you're doing
They're
it?
still paying for my my salary. They're still paying my
Mhm.
salary while I'm there.
Uh-huh.
So,
Very good. Nice deal. Yeah, nice deal. So what kind of hobbies do you have you'd like to do?
soccer, and I
Mhm.
like reading, learning new stuff.
Mm-hmm. Wonderful. Well, what a great guy. I mean, this is a great class. I mean, this is a good size, I think, although the lab wants to grow it to more, but this is, this is a good size of it. Okay, well, let me move on to me, tell you a little bit about myself. This is probably one of the favorite things I've ever done, one of the memorable things. This is on the Rootburn track here on the South Island. And you've done the Rootburn track?
No, that's the one where we'll pick up.
Unbelievable. Unbelievable. So, so I recommend that. There's a Milford track too. The Milford track is probably the most popular one, but I don't think it's as beautiful as this one, the Rootburn track. 3 days out. So a little bit about me. My educational background is electrical engineering. I did my bachelor's at Duke University, and then I did some graduate study, didn't finish it at Ohio State University, and then I went to England and did my PhD in Southampton, England. Turns out, like you, Maura, the Air Force paid my way. So that's the way to go to school, where you're getting your regular salary and they're paying your way to go to school. So basically, I spent the first part of my career after graduating from Duke University in the Air Force, and at Wright-Patterson Air Force Base, which is the mecca for military R&D. I mean, there's no place like it in the world. And basically, I was design fighter cockpits, advanced cockpits for military aircraft, primarily fighter aircraft. And one of my last projects there was called the super cockpit. And this super cockpit is a cockpit that you wear. And I'll be talking about that a little bit later. You put on a magic flight suit, plug into the cockpit, and now everything is presented to you in 3 dimensions, to your eyes, your ears, and to your hands, and things like that. And so that's when we invented what is known today as virtual reality. Way before anybody even knew about it, we were doing it. And the term virtual reality actually was promoted by a guy by the name of Jaron Lanier. But this was several years after we'd been doing it. But and that's the term that sort of stuck, virtual reality. But prior to all of this, as soon as I graduated from Duke University, I actually spent a short period of time working for Procter & Gamble. You guys ever heard of Procter & Gamble company? And I was responsible for a production line that made Scope mouthwash. Let me tell you, that was a life experience working on that. So I now have, well, actually that 45 years, this is an old slide, should be about almost 50. 50 years of working on user interfaces. So the bottom line is I've done it. You know, a lot of people talk about it, read books, give lectures, things like that. But I've actually done it. And there's stuff out there that's working, because of that. And there's stuff out there that's not working because of it. So it's sort of the school of hard knocks. And the problem with user interface design is it is not a science. It really isn't. It's really just an art right now. We have some principles and guidelines and tools and things like that. But let me tell you, we still don't have a clue what's going on in the brain and how people, really do interact with these things. We get hints by trying out things, but it still is an art. It's not a science. Just sort of like medicine. You know why they call it the practice of medicine? Because they're still practicing. They don't know what it is. They just sort of play around and hopefully get some of it right. So this is what I worked on. This is one of the airplanes I worked on. This is the F-15, F-15 Strike Eagle. And, my job was to figure out how to get that guy right there, hooked up to 50 computers while you're flying twice the speed of sound, pulling G's to where you're about to pass out and being shot at the same time. That was the job I was working on. And these were the early cockpits in the F-15. There are, about 300 switches and 75 displays. 11 switches on the control stick and 9 switches on the throttle. And you got to remember what all those things do.
It must have an incredible process information compared to situations.
Yeah, you'd hope so.
I hope so, yeah.
Yeah. But it is so complex. And what we did is over a period of years, we changed this cockpit to something that looked like this. And now you have, this is sort of a modern fighter. Well, not the most modern fighter cockpit. You see this wide field of view head-up display here. And you see these electronic displays. And you think, okay, wow, that's really an advance. But it wasn't, as it turns out. Because what this did is give the pilot so many options. You push one of these switches here, guess what? Everything changes. The number of permutations and combinations and symbol sets that you could have on those displays, overwhelming. Furthermore, this display could move over here, this display can move down here, and at least in the olden days, you knew where to look to get a piece of information, even though it was a highly coded piece of information. Now, you didn't. It was the way it was organized. And the complexity, for example, the radar on the F-15 radar has 60 modes in it. Just the radar now. There's a lot of other systems on there. The manual for the radar is that thick. 60 modes. And how many modes do you think the pilot actually uses? Maybe 4. But you have to learn all those other modes. It's daunting. That's just the radar. That includes your electronic warfare system, your stability augmentation, your fly-by-wire, all those other systems that are there that help you perform your mission. So that was a problem. And then, of course, my work was about 20 years ahead of time before it got into the actual airplane. We were working on the F-22 Raptor, which has a cockpit that looks like this. So can you guys see that okay? Is it too bright in here? Can you still see me with?
Yeah.
Okay. Can you imagine flying at night with this thing and trying to keep track of things? And this is a single pilot now that's doing this. You don't have a co-pilot over there next to you that's helping out. Okay, so what am I doing now? Well, I'm a professor. I beat my sword into a plowshare, became an academic, sort of an academic. So I'm a professor in industrial engineering, systems engineering, electrical engineering, mechanical engineering, human-centered design and engineering. Then I'm an adjunct professor here and in Australia. So I founded this HITLab in the U.S. in 1989, and it grew to about 120 people. We spun off, actually that's 27 companies now, have about 100 graduates, and built a consortium of 50 companies that help support the lab. And I have 19 patents now, this is an old slide, and about 5 that are pending. and then consulted for lots of people. These companies, I was on the board of several of these companies, and several of them used my patents and things like that. So I started this lab here in 2002. I came here in New Zealand, Christchurch, sister cities, came to Washington, looked at my lab, said, can we do that here? I came down here and spent some time, and then we decided to do it, only we needed a director for the lab, and so we hired Mark Billinghurst as one of my students. Mark was my PhD student in electrical engineering, and so he was a Kiwi. I said, Mark, you have to go back and come and run this lab. And I'm not sure Mark wanted to come back and run the lab, but he did, and he's sort of done the same thing. He's done some wonderful stuff here. And Mark and I founded a company called AR2 Works. You may have heard of that. They're the original guys that did the AR toolkit and still exist. And then one of my private labs is called the RAT Lab, R-A-T Lab, for Rocking and Thinking. RAT is Rocking and Thinking. And that's where I play outside the university. Some things I want to do in the university, some things I don't want to do in the university. So we've done some neat things, like we had a project with Bell Helicopter where we were actually designing a new cockpit for a search and rescue and emergency medical services helicopter for Bell, and that would land at night and do all these kinds of things. And so I bought this house down the street from my regular house, which I turned into my RAT lab, sort of like my garage. Well, the whole house is chock full of electronics. One of the bedrooms was a helicopter simulator, and where we did this virtual cockpit stuff. In other labs, we fab electronics, and others we, just have a big time. You notice here there's U.S., New Zealand, and Australia. There's also, you see this UK here. Well, the UK lab didn't really happen. It's supposed to happen, but I'll tell you that story another day. My family, we're, by the way, that's Haley there a few years ago. And yeah, it turns out Jonathan knows Haley. That's Haley's mom right there. So these are my two daughters and their kids, and my wife with the purple hair, and me. This wild family, Yeah. Now, I was going to give you a design problem, but I'm not going to do that. But here's what I would have done. I would have asked you to design a wheelchair for a person who's blind. And I was giving you 5 minutes, and I'll let you sketch that and then turn it in to me. Okay? And so this was going to basically, you would, why don't you do it? All right. Okay. Get your sheet of paper out. I want you to design a wheelchair, and I'll give you 5 minutes to do that. Okay? So there's the timer. You can do a block diagram. You can do, anything you want to. You too.
convincing way of teaching.
About 1 minute left.
Is this such a good idea, having one person in a wheelchair?
Should we have just drawn a big X on the page?
Yeah, it's sad to think that.
It has been done. Is being done.
It is being done.
You can ask the question, is it a good idea for a blind person to walk?
Have you seen the blind kid who can use sonar detection? He clicks with his hand.
Okay, that's it. Okay, let's turn those babies in. Okay. Thank you. Thank you, Murray. Okay, so I'll spend a little bit of time later looking these over, but okay. So how did you address this problem?
I started by thinking about a public scooter,
Okay, so you have some experience
which is not like
with
that.
that. Mm-hmm. Yeah.
Some of the pictures of that
Mm-hmm.
would be useful in the same design.
Mm-hmm.
I jumped to what senses and what you can do, so immediately the sound. And then I started thinking about, so sonar detection came to mind, like bats. But then I started thinking that just because you can't see it doesn't mean you can't use cameras for motion detection. long enough to build it.
Okay.
Yeah, I did that, and then I thought, what would be critical, like having, if there was something really close by, you'd want to alert for that. So
Mm-hmm.
put that into the joystick.
Mm-hmm. Yeah. So you had an instrumented joystick here, I see.
Yeah, I didn't.
Mm-hmm.
Sort of classical wheelchair apparatus.
Well, how about you, Moore?
I thought of how blind people currently go about on the street if they're walking or if they're using a dog to guide them through, and what they currently do. So if they're currently walking, they have the walking stick and straight to each one. So I thought the sensor underneath the wheelchair that's sort of looks for solid objects and tries to detect motion. And then I thought of how if there's, for example, if there's a notification or they need to do something quickly, like there should be a speaker that sort of notifies them or something like that. And also a camera on top that's should in case of emergency, or maybe there's something like crowdsourcing where people can guide them when they get to maybe if they go to somewhere where that technology can't really help them with sensor technology, the camera will sort of provide a live stream to other people elsewhere.
Okay.
Another good starting point here is here
Mm-hmm.
hybrid law.
Mm-hmm. Well, see, all these are really good ideas. I mean, you have to start from somewhere. And I think these other questions are associated with that, but you didn't have a chance to go through all of these things in terms of assessing your ideas and things like that. But there were some limitations that you may have. I mean, you're making some assumptions, but these assumptions were generally based upon your own experience, right? What is the missing thing that you have in terms of your own experience? You're not blind, right? And here you're trying to design something for a blind person. And that's the first rule to remember when you're designing interfaces, that you are not the user. I mean, you could be the user, but depending upon what it is. But you got to put that user, the potential user, into the loop for design. Otherwise, you find all of these wonderful things. We did this in the past with cockpits. We designed cockpits that the test pilots would evaluate, and they loved them. The problem is, all those test pilots were engineers, and they love technology. But you take it out to this guy that's out there on the flight line and operations. Guy's an English major, and he just wants to get the job done. He didn't care about all, bringing up the scores on the latest rugby game and things like that, which you can do in your cockpit, just wanted to get the job done. So we found that there's a huge disconnect from the engineers versus the people who actually operate these things. So you had some deficiencies. You have limitations. First of all, you don't have any personal experience in this, right? And oh, by the way, there's a real problem with putting a blind person in a wheelchair because it really destroys their spatial map, because they build their map by walking, right? And so now if you're riding along, you miss that. And so going back and doing it again, you're basically destroying a map. Lack of knowledge about the user population in general, unless you have a member of the family or something like that that you've been associated with. At this point in time, you have varying degrees of user interface design experience, right? And a lot of it that you've picked up along the way. And that's one of the reasons for this master's course, is you're going to get those principles. And then actually practicing it, actually doing it over and over again. There's no better You can't take the place of that, because the doing it, you learn a lot more than actually even looking at the principles. So we're going to solve these deficiencies, hopefully, for you. With the exception of number one, we aren't going to blind you in the process of getting you there. Okay? Well, maybe we will, but we don't mean to. So there are all kinds of things that you can do in addressing a problem like this. There are sort of these evolutionary designs. If you give let's say an adult, design a computer for me. You know, what they do is they draw this box that has a screen and have this other box that bumps into the screen, things like that. And that's, you know, and it may go a little faster. It may have a different little keyboard design or something like that. But that's a sort of an evolutionary design. You know, but you give this to a young kid, I mean, and they don't necessarily have, well, they're getting younger and younger now, but any preconceived notions of what a computer is like. But you say, this is what I want it to do. They'll come up with something entirely different than what you have in your head. So in some ways, you have to purge yourself of the old thinking. Not all old thinking is bad, but the revolutionary designs really shake things up and stimulate the thinking. And usually what happens is you get an a merging of the evolutionary with the revolutionary. Because the revolutionary may be too much. And so but it does pull along the evolutionary design. And all these things about paradigm shifts. For example, in the case of the wheelchair, you know, doing a lot of automation in that, you know, that there is there's a feedback control system that lets you navigate. You may give a command to say, I want to go to the Starbucks on such and such a street. You know, and then the GPS is there, and basically it takes you there, watching out for other pedestrians and cars and things like that. So there's this whole automation thing. Then there's the feedback, where you have the feedback. You mentioned the tactile feedback. You mentioned what are the sensory capabilities you do have without the eyes. Auditory, tactile, for example. And then, of course, you build in all kinds of sensing into this, visual, and the visual spectrum and infrared spectrum, ultrasound, things like that build this confluence of this chair. But even then, it's just like what I showed you in that modern cockpit. We took away, in the process of going modern, we took away some fundamental things that were there in the old designs. Because if you wanted a piece of information, you just looked at it. You know, so just a ballistic movement of the eyes to look at that particular instrument. But now with the fusion of everything and when it can all change, we took away that. And this is a way that wheelchair may take away the ability of a person to form their own mental map. You know? So we have to remember that just because we make it modern doesn't mean it makes it better. We may take away something that is important to have. So if we look at what's going to be happening in your master's program, and you've gotten this before already, I'm sure, that but this is the way I view it, and I was one of the architects of the master's program. We wanted to provide these four things: the knowledge of how interfaces seem to work. Now, I use the word seem because it's not a science, but we can make observations. And then what can you do in terms of having a set of tools that you use for doing this? By the way, the easiest tools, are the hardware and the software pieces. The more difficult tools are what does it have to do with a human and how do you test it and evaluate it? Those are actually more difficult to do than coding or burning solder, you know, and making these things. Those are sciences, okay? But the other stuff isn't. It's the art. And then this process that you'll be going through and a project that you will work on that lets you apply it. And that's what we're trying to cram into this this 1 year period, which is ambitious. Most of the master's programs are at least 18 months and often 2 years. And we're trying to cram this all into 1 year, which is difficult to do. I mean, you're going to be busy boys during this time. Now, I plan in 13, I did 4 lectures. Actually turned into 5 because I'm so slow in getting through this. I tell all these war stories, you know, on the long way. I'm hoping to do that again this year, but right now I'm only booked for 2. I'm going to assume that I'm going to do the 4, okay? But we'll have the first 2 this week, and then and start off with some initial definitions, and then tomorrow we'll talk about sort of the human side of designing interfaces, and then the next one will be the machine side, and then how you put them all together into some applications. Okay, so we've done the introductions. You've done your sort of design, your initial project. What I want to do is go through some definitions, talk about what is the goodness of an interface. You've gotten some of these before. Give you some interface examples, why they need to be designed, and some models to think about in your assignment that you'll have to do for tomorrow, okay? So let's go to a few definitions. And by the way, you guys should have all these, you'll have all these slides. So they'll be on the course website, I assume. That would, you've gotten the other ones, haven't you?
I have the old ones.
You have the old ones. old ones. Okay, let's start off with technology. What is technology? Well, in the Encyclopedia Britannica, which you rarely see anymore, but it's this application of scientific knowledge to the practical aims of human life. Practical. That definitely, I don't necessarily agree with that, Dan, because we do a lot of technology because we can, not because it ought to be done. And we see that everywhere. This so-called creeping featureism, that you do it because you can do it, not because it needs to be done. We make life more complicated that way. Anyhow, practical aims of human life, or as it is sometimes phrased, to change and manipulate the human environment. We've been tool builders. Humans have been tool builders back from, ancient times, right? We use these tools to extend ourselves, the things that we couldn't do by ourselves, but we use them to empower us, to extend us, and things like that. Okay, there is an alternate definition of technology. The human development of tools, the scientific move forward revolving around laziness, right? For which the body of human society is willing to step on and mangle its future, okay? And this came from the Devil's Dictionary of Technology. Okay. Now let's add to technology a tool. Tool is a system of technologies that helps a user perform a task or tasks. Okay? Now, let's talk about what are some tools. Here's a tool. You can do things with this tool you can't do otherwise. I mean, you could probably do it with a rock, pounding a nail or something like that. But the lever arm that you have here, it's a very useful tool. And you see also some safety things here that go along with that tool because something might happen that you don't anticipate that can injure you. Here's another self-contained tool. All of this using basic physics, right? Lever arms, things that are harder than your flesh. Here's another tool. This is a self-contained tool. A video recorder, a camcorder, that you can record some video and play it back. By the way, this is a long time before we had this stuff. This is when I made these slides. We do this on our smartphones now. Here's another self-contained tool. Any of you ever been kite surfing? So, it's sort of all built in there, but you do depend upon Mother Nature to help out some with kite surfing. But you basically have a parasail, and you have a what's equivalent to a snowboard that you're running on the water, and it's great fun. Okay, now tools can be part of a system. These other ones I just showed you were self-contained, right? All embodied in one. But let's look at this. This is a tool which is part of the system. So what is the system that this tool is associated with?
Washing facilities.
Okay, this is what you do with it. This is what it does. Okay? It brings into your home the flow of water. Okay? What else?
I think it could be part of lots of different systems.
Yes, tell us about those.
It could be the toilet.
Okay, so there is another part, end user part of this. That's yeah. But what is underneath this? What are the subsystems underneath this system? All right, plumbing, pipes, the conduits for this liquid, right? Yes.
That can be integrated into, as Mo was saying, like all of your kitchen for cooking, and so washing your food and making it sanitized. But you can also put it in hospitals for the doctors and preparing for surgery.
Right. So it has a number of applications. So that's the application side. That's the outside part. But what's the inside part? You mentioned the plumbing.
The joints.
Sorry?
The joints.
Joints in there. What else?
Brackets.
Yeah. Water. Where does the water come from?
The tank. There is one.
Where's that come from?
Yeah, well, the kitchen.
Okay, where's the catchment come from?
Sky.
What's happening from the sky?
Right.
Where's the rain come from?
What's the evaporated?
The weather system, I suppose. You're right there. It's coming from the environment.
Yeah. And?
It's cycling. The water cycle.
It's one system, right? When you think about it. You have a hot water heater in there too. All this. So this is the user interface part of a huge system. When you think about it, huge system. It's back. When you turn that faucet on, think of all the things that are happening, including those little drops of rain coming from the sky, and where those drops of rain came from, where the moisture came from. Right? Huge system. Here's another one. Television. Think about the system that's behind that. All the way from, when you had broadcast television, that was one thing, but now cable TV. Eventually there were some transducers along the way and transmission lines and things like that.
Satellite.
Huge. Even with electric lights, the same way, right? Most of New Zealand's hydro. Now we go back to the water again. Yeah. Tassie's sort of mostly hydro too, right?
Yeah, I think they're trying to put in now the very north they have those wind turbines.
Oh yeah, right. Look at this one. Radar approach control. Boy, there's a lot of components here. So you have the whole idea is to see these airplanes in the sky, right? Using radar. So in this case, these guys, they can use radar. As far as the airplane is concerned, it's passive. Because you're sending out a signal, bang, it's reflecting back, right? You're picking up, putting it in a scope. But how do you know what the identity is of that airplane is? So you do an IFF. Sort of as a transponder on the airplane, you send it. You send a signal out and says, "Who are you?" And it sends back a code. It says, "This is who I am. I'm Air New Zealand Flight 454." And it shows up on the screen. NZ 454. And there's a whole system that makes that work. You talk about the power systems, you talk about the radar systems, you talk about the transponders in the airplane. Power supplies that run the transponders in the airplane. Turbine engines, fuel that runs those turbine engines, the the refinery that refines them, all back to drilling into the earth. And where did that come from? The dinosaurs, things like that. So you see that everything is connected. Okay, so tools, the end user part, could be part of the system. Now there are tools that manipulate matter, right? This is a tool that manipulates matter. Drill press. Here's another one.
Manipulates matter.
Yeah. This is a very famous, I was telling you about this. This is a very famous toilet. This is the toilet that's in between two offices, Hewlett and Packard, the original offices in Palo Alto, California. This is a shrine now. It's actually like a museum. And I was visiting that. I had several projects at Hewlett Packard. And I asked the person, can I use that toilet? Because I wanted to sit on the same seat that Hewlett and Packard did. I felt it. It would ooze up through my body. I would get all this new insight. It was all that. I said, oh, no, you can't do that. We don't use this. Shame. I could have learned a lot from that.
That just reminds me of the astronaut thing.
Yeah, that's right. I'll tell about that. I'll even show you some pictures of that. Okay, so then there are tools that manipulate bits. You know, the others were tools that manipulate matter, right? These are tools that manipulate bits. Telephone, smartphone, DVD player, TV. What is this? This one here.
It's a stealth mode. No, that's high-level surveillance, isn't it?
The Blackbird is the SR-71. I worked on this airplane. Didn't know I was working on it at the time, but I was working on it.
That's the high flyer, isn't it? Why is high? That's surveillance.
Mach 3. 3 times the speed, beyond 3 times the speed of sound, up at around 80,000, 90,000 feet. Yeah. But why do I call it a bit? To manipulate bits.
Digital data.
It's a reconnaissance aircraft. What it's trying to do is look down on the Earth and see what's going on. So it's acquiring data and storing it to see what the bad guys are doing. Right? Now there's also tools that manipulate energy. We have bits, matter, energy. This is a power plant, right? And so this is controlling all the turbines, and this is a nuclear power plant. And lots of things going on in the power plant. This is an M1 tank. It manipulates energy. It takes energy from one point to another and then delivers it, right? And here's another tool that manipulates energy. This is the Phantom F4 aircraft. This is one of the aircraft I flew on when I was working for the Air Force. And so it basically delivers energy from one place to another place. So these are tools that manipulate energy. Okay, now what is the interface? The interface is that subsystem of the system that facilitates user interaction with the tool. That's the interface. Okay, so then let's add to that the actual interaction. Interactions are the actions and processes that take place between the human and the tool through the interface. Okay, so you have these three working together, and all of these are made with technology. So another definition of the interface is the word interface is interesting because inter, I-N-T-E-R, means between, and faces, right? Faces. We have an interface, humans have an interface between faces. And we use words, we use expressions, things like that. But one of the faces can be a machine. So you have the human face and the machine face. Somehow you want them to be able to communicate with each other. So when you think about the interface, you say, well, what is it actually? What is it physically? So as it turns out that even God didn't understand this completely, because Peter was saying here, you just can't punch in "let there be light" without writing the code underneath the user interface functions. Right? So where is the interface? Okay, what is the interface here? Is the interface this thing here, these buttons here, or is it what's underneath here, or in the wire, or is it basically a processor that all of this is connected to? Is it the ICs that you're using and the way that the signals are manipulated in it? Is it the wires that send the signals around? Things that you press on the keyboard? So where is it? Or is it the cognitive side of things? This is probably not a good example of cognitive. But,
He is trying to think about it.
so we probably don't want to go there. Anyhow, so where is it? So it turns out that it's all of the above. You know, you can't say the interface is just the thing that you touch. There's a lot of stuff underneath it. A lot of stuff. And you can't get the thing that you touch to work unless you get the stuff that's underneath it to work. So there's a lot more going on with interfaces when we talk about interaction design or interface design than just this physical. So what you do, of course, is put these together, the tool and the technology and the interface. So here we have an SUV with this power plant. This is the tool. The tool. What does the tool do for us? What does this tool do for us? Yeah, moves mass from one point to another point. And the technology that is used to do that, one of the technologies is to use refined crude oil that is mined from the earth in an internal combustion engine. But the interface, especially the human interface, is this, steering wheel and other controls and things like that, accelerator, so forth. Same can be true with the computers. So you have a tool, you have interfaces to the tool, right? Televisions don't look like this anymore. Here you have sort of things built in, all built in. Now, the interactions that take place are, how do you interact to perform a particular task? In this case, your physical interaction and holding the hammer, handle the hammer, and guiding it in a way that you're able to make this other piece of matter go into a piece of wood. Okay, what is the interface to this tool? You've sort of seen it before. And this, sometimes though, you want to design interfaces so that they actually are intimately coupled to the human. Now, this is intimately coupled, certainly, right? But here we have this is an F-16 cockpit. And this pilot is looking at an object out in the world. The question is, how do you take advantage of that? This is the problem I was trying to address many years ago. Because what they would do before is they would basically have to aim the airplane, to aim the systems on the airplane. When in fact, you could see objects all over the place. But you would have to fly the airplane to aim it to those things. This is a real problem because it's very difficult to do that, especially when you're going fast. Because when you're turning the airplane, that means you're pulling G's. And if you're doing it, if you're going really fast, you're making a big turn, you'll be pulling a lot of G's. And you black out as a result of that. So this is one of the problems I was working on a long time ago. And one of my, inventions was how to do that, how to instrument the pilot's helmet. Where this crew member is looking, I actually aim the systems in that same line of sight. So here you have a helmet. You project on that helmet a reticle, sort of a target, at an optical infinity. Here's in the distance. So you have a line of sight. And then lined with that line of sight, you have 2 photodetectors on each side of the helmet. And you interrogate those photodetectors with a scanning infrared beam of light. And then you time the scanner and you get the signals back. And you triangulate on these 2 points. Draw a vector through those points. Resolve that vector into azimuth elevation angles. Then you use it to steer things. You can input a computer. You can steer a missile seeker, radar, all kinds of things. Okay? Just by looking that direction. And this was in 1968. I did this. Here's Lieutenant Furness wearing the world's first helmet sight system. And so here's the projector here. This will look through this reticle, the optical infinity, and then you aim at the target. Aim systems in it. Okay? So we want to know how well this would work. So yeah, it worked great on the ground. How would it work in the air? So we said, well, let's go out and fly it. Let's put it in an airplane and try it out. This was one of the test aircraft. And another one like this was a target aircraft. We had these guys going up there flying around, and we were trying to measure how well a pilot could actually track a target using his head, and using this technology in aiming systems on aircraft. And so here's the F-106 installation. Here's the scanner right here on the canopy rail. Here's the helmet with the sensing things. This particular projector, reticle projector, you could switch to either eye that you wanted to use. And so you'll be flying along looking at these targets. And what we found out is it really works. Even at pulling G's, when the pilot's up to 6, 7 G's, that's 6 or 7 times your weight. You know, if you're weighing 200 pounds, you're 1,400 pounds.
When do you black out at 8?
Well, it depends upon the onset rate, the G onset rate.
Okay.
Because you're wearing a G suit. You're wearing a special suit that squeezes your body, tries to keep your blood up into the head. But if it happens really fast and blood drains out of your head, then you're out like a light. But so here you can even look behind you, because we have missiles now turn corners, you know. They can actually go behind you because thrust vectoring. So we measured what the line of sight was between the pilot and the outside thing. And we found out that pilots could track. What we do, we put some Kalman filtering into the tracking algorithms. We found out that these pilots were tracking with 0 mean error. I mean, they were spot on, even at these high G rates. I mean, in high speeds, large angles. So there's some other interface examples. You've already talked about the door stuff. I love the door illustration because this is what we call an affordance. Have you gotten affordances yet? You talked about affordances? Yeah. Probably gotten that from Andy Coburn. Some of this. You know, the design that in itself tells you what you have to do. This handle does. Your handle gives you, you know that you have something that you grab onto, you know, and that, and in some cases you will actually turn it in order to open the door, or a push bar. It's got what's really confusing is doorknobs. Doorknobs are the worst kind of user interface for a door, because first of all, you don't know which way to turn it, right?
Yes.
And you don't know which then you're supposed to do with it. You know, pull in or push out unless you look at the door jamb, things like that. So interfaces here, we've talked about that. Interfaces here. Here's some interfaces for matter manipulators. We've seen this one. But have you ever seen the interface for a backhoe or a steam shovel? You ought to sometime. It's the least intuitive thing in the world. I mean, you've got to get used to all these levers, pulling these levers and things like that. and in order to know, get the arm to go out and scoop up and move over and things like that. What would be a better interface? This right here. This is a modern one, by the way. It's a joystick. What would be the best interface, do you think?
Just think about it.
Yeah. Thinking, oh, is there a pile over there? I want that hole there, and I'm going to put the dirt there. You just think about it, and it goes and does it. Right? You don't even have to be there. You could be somewhere else. Or, when you get back to more conventional technology, what if you just put your hand out? We can do that. I mean, we have the technology to do that. This is a pretty awkward way of doing things. But, after a while, you get to be skilled. And by the way, these operators don't necessarily want it simpler. You know why? Exactly. When they come up with the new radiology machines, radiology machines, the old radiology machines. Am I okay? Did I drop my pen? The old radiology machines. They were so complex. They had all kinds of controls on them, And these radiology operators, talk about ultrasound operators. Ultrasound were really complex. They had all kinds of tweaking you had to do and things like that, get them to work. And then they came up with these modern ones, where you just sort of push the go button, and it all takes care of itself. It was completely resented by the radiologists, ultrasound operators, because what did it do? It made everybody ability to do it, and not necessarily interpret it, but certainly operate it. Same was true with the telephone system. We used to have telephone operators, right? That would put the plugs in and things like that. Now everybody became a telephone operator by dialing the number. And so it's interesting how technology is resented by those who do it the old way. And very difficult sometimes to get things done. This is true in fighter cockpits too, by the way. The old heads don't like the new stuff. But the new guys coming along can catch up with the old guys really fast because the technology's better. And here's some interfaces. We've talked about this before for interfaces for energy benefit. So there's evolving interface. And as I mentioned before, we see a huge paradigm shift here between these two, right? Here you had to have another human in the loop. Here you didn't. And it turns out this interesting study was done by Western Electric, the part of the Bell system, in the U.S. in about 1915 or something like that. 1915, 1916. Maybe up to 1919. Anyhow, the study was how large can the telephone system become? And they studied it out, and they looked at the demographics, and they said, well, you're only going to get, at the most, maybe 3 million subscribers, 3 or 4 million. Why? Why do you think it was limited? In particular, what was the problem?
Oh, it was the phone.
You can only have so many people that were telephone operators. Yeah, and then of course there are systems of telephone because you only have so many. Each telephone operator had all the lines there, that plug into. And so it became daunting because you can only have so many telephone operators. So the paradigm shift was you become your own telephone operator.
Shift.
Big shift. huge shift. And then, of course, we know what happened, as a result of that. And now, you can be having a conference call. I had a conference call last year where one guy was in a taxi in London. There's another guy in Australia, another guy here, and one in Seattle. And they're on this conference call with each other. And we were communicating about something. That's pretty amazing, actually. Then, of course, this is what the telephone operator used to do, right? This is a console, and this is what they look like now. I mean, computers are really boring nowadays. I mean, used to, even when we had computers, you had indexing tapes and all these disk drives going, and you had a plenum floor, and you walk into this room, and you have this huge noise, blowing air through these things. And this was a real machine, let me tell you, and all the lights were blinking and things like that. It's so boring now. You just have this little box, and it just, what is it doing? You can't see the electrons. Used to, when we were working on the PDB-8s and things like that, you could hear the core. You could hear the magnetic core in there. It would sing. You put your ear up to it, you know where the computer is in running its particular algorithm by the way the core would sing. Don't get any of that stuff now. So this is an electronic switch on the right, how our telephone system works today. And of course, you can do a gazillion, calls at once through this kind of thing, through optical fiber and so forth. And so we see this huge demand for new interfaces.
They didn't produce an instruction manual for business.
Sorry?
They produced no instruction manual for VI.
I didn't understand the question.
They didn't produce an instruction manual, but you taught them how to use it.
That's right. Yeah, the instruction manuals are out now. Nobody reads instruction manuals. So if you look at the most modern things, they expect it to be so intuitive, and that's part of the interface design. It's got to be intuitive, but you have to make some assumptions that people have come along, with other, they know how to do touchpad type things and so forth. But yeah, there are no instruction manuals. You can get stuff off the web, but you have to figure out how to get to the web to begin with. Yeah. But what we're finding now, and this is a revolution that's happened, is people want more and more stuff, right? They want more stuff. So the way that, there's a difference in philosophy between Apple and Samsung. These are the two giants, right? Apple and Samsung. So Apple systematically goes through design process and making sure that design is elegant, and it's beautiful, and that they use a lot of user interface testing. Samsung doesn't do that. Samsung just throws all the stuff out there and sees what sticks. All right? Now, who's to say which part is better? Which way is better? Certainly, one of the things that happened is very interesting, that when Apple did all their initial studies on the size of the iPhone, they spent a lot of time on this. What should the optimum size be, right? Holding something you'd use as a telephone instrument and all these other things. And this form factor was the standard for that. But then, and people there were some earlier smartphones, who were larger than that, completely rejected. People said, no, it's too big. It's like holding this brick up, things like that. Then what you found is this emergence of larger size, format size. Why? Why did that happen? So now if you look at the Galaxy, the new Galaxy, it's huge. And people are accepting it. Why? They didn't before. Why are they now? It has to do with they've gotten addicted and seduced by what's on the screen. And now they want more on it. And they're willing to accept the inconvenience of having this bigger form factor in order to get more screen. So that shows you what happens in the evolution of technology. Something that would formerly be rejected is completely ridiculous, is now accepted because you want the other part that comes with it, that you can get more screen, more screen space with it. And we're seeing this other thing that's happening with the iPad. Now, I've got every version of Apple stuff that's ever been made, and I'm an investor in Apple in more ways than one. And every iPad that's come out, I have all the iPads. But then this iPad mini comes out. And I said, well, why would you want that? Because it's smaller, But I love my iPad mini. Because it's really easier to use. It's got all the features of the big iPad, but it's just a little bit smaller. But it's so easy and so light. I can stuff it in things where don't take my big one. So Apple has me. They have me hook, like, and sinker. They could just throw something out there and reel me in, and I'll buy it. Anyhow, really interesting about what's happening with interfaces and how the interface is everything. Pretty much all the smartphones have the same thing on the inside. All the computers have the same thing inside. Intel inside, It's the outside and how you interact with it that makes it better. And this elegance. The elegance of this iPad mini, this MacBook Air. You notice that everybody now is copying this form factor with the lightweight and things like that. But that all has to do with the likability of an interface. So we're going to get to that in a minute. Now look what's happened. Nintendo made a revolutionary change in interfaces for games a few years ago with the Wii. Because up to that time, you were playing games like this, right? And that is just like eliminating those telephone operators. What happened here is you use your whole body as the interface. You use natural movement as the interface rather than some arbitrary movement like you have here with your fingers. I never could beat my grandkids, with the great game consoles. They were, I don't know where they learned all this, but they were pretty good at it. But with the Wii, I could beat them, and bowling and tennis and all those other kind of things, Not only that, there's a whole phenomenon that's happened called rehabilitation. Old people in nursing homes can play these games now and use them for rehab. And now with Kinect that came along after it, with the Kinect camera and things like that. But the Wii guys, Nintendo, made a huge paradigm shift. It was a real gamble on their part. While Sony and Microsoft, the Xbox and the PlayStation, were striving for higher resolutions, for higher, fidelity in the picture, things like that. Nintendo was going the opposite. They didn't worry about the picture. They worried about the interface. And then, of course, the Wii became the best-selling game. It's not now necessarily. I think the Xbox has taken over, but there for many years the Wii just, stripped everybody. By the way, they came and talked to me before they did this. The Nintendo people in the HITLab US talking about this kind of stuff. So, in the end, we have these 4 definitions, but we have to add the 5th definition. What is the goal in all of this? The goal is to design this interface that makes the interaction with the tool the most useful in performing the task. Well, let's dig a little bit deeper in that. What does most useful mean? Is our goal to really get bandwidth to the brain, bandwidth to and from the brain? Probably, but not necessarily in the sense that we think about it today. So these are the 4 things I think are important for this interface. First of all, it has to be intuitive. Intuitive means that it's easy to learn. The slope of the learning curve is the highest for this. It's intuitive. That means you don't have to use as many resources to operate it. It needs to be effective in that it gets the job done, because the tool is there to help you perform something. The tool is not the end game in itself. It is a means to an end. Unless you buy a Jaguar. If you buy a Jaguar, this is my whole favorite story. If you buy a Jaguar, the whole object of the Jaguar is so it sit in the garage so you can look at it and leak oil. You know, but you can go out in the garage every now and then and look at it and say, oh, this is really cool. But you never get it out of the garage because it never runs, you know. But nevertheless, that's the tool needs to be effective, but it also needs to be efficient. Not only does it let you get the job done, it lets you get the job done in a timely way, right? And with a minimum expenditure of resources, of your resources, it takes for you to do it. But finally, and maybe most important these days, is you got to like it. We didn't worry about that in the old days. You know, you had one telephone, and that was it. But why do people buy things like this now? Why do you buy what you have, a Nokia? AT, what do you have? Nexus. Yeah, Google phone. And so others will have an HTC or Nokia or Samsung or an iPhone. What is it that distinguishes now? It doesn't have anything to do with its functionality in many cases. It has to do with if you like it. Likability. And how do you probe likability is huge. In interface design, it's going to be the huge driver, and that brings us all back to industrial design, interaction design, all those kinds of things. And why the HITLab, we're going to be on the top of the game for the next 20 years, because it's going to be design that's the big factor, because the technology underneath it is going to be ubiquitous, really. So why do we do interface design? Well, let's go to Dilbert. You guys know about Dilbert. Dilbert is an engineer. So here's Dilbert and Alice, his co-worker. So Dilbert says, I designed the user interface myself. How do you like the colors? He's asking Alice, how do you like the colors? Flu? No. Interface design. So she goes to her doctor to find out, what's going on. And he says, you have chronic Majobus crapus, but that's not why you puked. Why did she puke? Have you been exposed to any user interfaces designed by engineers? No. You have interface poisoning. You'll be dead in a week. So Alice goes to her favorite sanitary engineer to talk about the problem, garbage collector. And he tells him, I have 1 week to live. I've been poisoned by looking at bad user interface design. And the guy says, I see a lot of this. The only cure is to crowd out the ugly memory with images of staggering beauty. So what we are going to be doing in this course is to develop interfaces so people don't puke, right? And life will be good. Well, gosh, I was going to give you a break at 11, but I did. You just want to carry on to the end, or do you want to take a few minutes break, or?
Yeah, push on.
All right. Okay, I'm going to introduce this little model. It's something I developed over the years that we'll use as a guideline as we go through the next 3 or 4 lectures. And it's really a simple design. It's sort of this conduit. It's a pipe that has on sort of one end of the pipe what we call human processes, and the other end of the pipe what we call machine processes. And so generally what we do when we think about interfaces, we slice it down the middle. We take out this piece. There's air, in between the human side and the machine side. And so you even slice that further in the human side and machine side to where you have now sort of the first layer here, which is sort of the transduction layer. The transduction layer takes something that is one form and changes it into another form. In the case of the display and control input, this is the machine side. This is sort of like what I have in front of me here, right? It has the things that send out photons, mechanical vibrations of the air, touch. Yeah. These are signals that are sent forth. Why do I call them signals? Are they information? Do the transducers send information?
Bits.
They send bits. That's right. Transducers are only sending bits. It's the organization of those bits.
That makes sense.
Yeah. So now on the receiving side, we have the sensory end organs of the human. Our eyes, our receptors in our eyes, our ears, our touch sensors, things like that. So that transduces those signals, light, mechanical vibration, into electrochemical signals that go various places in our central nervous system, right? To our brain. So that the other way around, let's say that we say something. We give a verbal command. Or we touch something. Or we move our hands, fingers, or whatever. The machine can pick up on that, right? It can measure a contact closure. It can measure movement of our finger on a trackpad. Hear our voice, microphone, things like that. That transduces that signal into an electrical signal. So there's electricity on either side of this, right? On the human side, it's electrochemical, and it's electrons on the other side, the machine side. But then we have these other slices. Other slices from the human side have to do with perception. Perception is the way that these, and I'll give you examples of all these things. Perception is the way things are organized. So we take this sound and we convert it to audio spectrum, pieces of audio spectrum, and do pattern recognition from that. Pattern recognition happens at the perceptual level. And then at the cognitive level, you're actually making sense out of it. You're processing those particular forms of signals, patterns of signals, making sense of it based upon what? What do you have that helps you?
Senses.
What's in your brain that helps you make sense out of these signals? What? Experience, exactly. You've learned it. So these are all stored. So your cognitive process is comparing all these things. Oh, I know what that is. I've seen that. That's a Miata. That's a Mazda Miata. I recognize that. Okay.
Past experiences doing.
Now, some things are actually, I'll mention this a little bit later, some things that are programmed in already. Okay, now from the machine side, you have the organization of those signals or the pattern recognition of those signals. And then you have what we call the program. The program is like the content, that's going in there. Watching a TV show, or you're playing a game, or something like that. or you're running a Excel worksheet. That's the program. So you have these three levels here, and these three levels here, actually more levels than that. Let's add those other levels. Well, let's look at this. The signal level, which is just the exchange of signals. All that's going across here, this boundary, the face of the human, the face of the machine, as I talked about before, are just signals. So that's the signal level. But we also have some other levels. So what's happening is there is a model that the human forms based upon experience and training and other things, right? This is the memory, what's going in the memory. That's intimately connected to the cognitive functions. Cognitive functions are what pulls things out of memory, makes these associations, builds upon them, makes extrapolation, things like that. Machine side is somebody had to design the program. And so there's the designer. You guys, this is where you live. You're over here. You're designing all of this in order to get something going over here. And so there is an indirect path. That indirect path has to do with your making assumptions of what's going on over here. Right? And assumptions of the way all this works. So that's your model of the user and the machine. Now there's one other thing here, and that's what is this all for? It's all for performing this task. It's a tool. The reason that machine is there is so you can do this too. As a matter of fact, the machine itself, as I mentioned before, is not an end in itself. It's a means to an end. This machine is really helping me convey something to you, to help build a model in your head of some things that are going to be important for you to have in order for you to perform tasks in the future, right? So this task that they're working on now is building those models and those giving you those tools, things like that. Now this may sound elementary, but it's important, I think, to pull this apart a little bit to see all these moving parts that go into this interface design. This is what I call level 3. And so you have this meta communication thing. So this is the communication between the user or the participant and the designer. Now usually, the user doesn't think too much about the designer other than to swear at them because of the poor design that they did, right? They don't, rarely does the user say, well, I really like this thing. They usually say, this is crap, you know. Okay. So the question comes back now, where is the interface? Well, there's certainly an interface between this and this, right? There's an interface between this and this. The interface between this and this. 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 You have to know what the person's trying to do if you're going to design a tool to help them accomplish that. And then the human's interacting directly with the task through the machine. The interface is everywhere. That's the problem. It is not just this transduction level or the pattern recognition level or the programming level. It's all of the above. That's the problem. So where are these interfaces? Everywhere. And by the way, when you're really doing interface design, you have to look at each of these paths and understand what's going on. And that, hopefully, is what you're going to learn in the process of doing this. Okay. The last few minutes, we're going to talk about gadgets. I have one of my team of students at the University of Washington. Even now, they're doing it now. I meet with them once a week. I have 24 students there that are doing various projects, independent studies projects. These are not class. This is not class. This is independent research. But these are undergraduate students. Well, there's one PhD student. And one of the groups is called a gadget research group. And what the gadget research group does is go out and look at gadgets, and we buy a bunch of them and play with them, just to sort this out. But I thought that since this has to do with interfaces, we ought to look at some of these gadgets, see what you think. So this is interesting, the Life Hub. You guys have probably not heard of this. This is actually a hypothetical gadget. It's actually using the new bendable, flexible screen technology. And so this group said, well, what could we do with that? And so they were looking at these concepts of where you can have, you can use your device this way, or you can wrap it around your arm, or you could plug in a little camera to it. And so this is a way of thinking about things. If you had this what if question, if you had a flexible screen, touch screen, what could you do with it? And that's what this particular design group did. And so this gadget research team were looking into that. How could you think about what affordances could be provided with new technology? Okay, here's another one. Now, the Galaxy S5. Now, this is one of those examples where you throw something at the wall and see what sticks. One of the things that's in the Galaxy S5 is basically a heart rate detector. They have it built into the camera thing here. Turns out they had an iPhone several years ago, but where you just put your finger on the camera and you use the light source to light up your finger, and you turn on the light source, and it'll tell you what your pulse rate is. You can even get pulse oximetry from it, it turns out. But anyhow, the Samsung has incorporated that into in the mainstream of their Galaxy S5. So this is a strategy. And they use this creeping featureism as a means to attract people to buy this. Well, all these things you can do with it. Well, you find out in the end, that sort of people get sucked in to buying it, but then they never use that stuff. Just the same with me. My example was several years ago, this is before DVD came out, I was determined I was going to get a higher resolution VCR player, right? You guys know what that is? You do know what a VCR is. Okay. Okay. Anyhow, I had a two-head system, and it was low fidelity generally and not very good audio. I was going to get the top of the line. I wanted the best. So I went to my local hi-fi shop and video shop in Seattle to buy one. Saved up my money. I was going to buy one of these. Told my wife, I'm going to get one. And so I show up at the store, and it looks like the cereal row in a supermarket. All the cereals, breakfast cereals. Oh my goodness. Where did I even start? And finally, I went and talked to the guy and said, can you help me here? Anyhow, I came down to two VCRs. One was made by Panasonic, and one was made by Sony, side by side. Panasonic had 109 features. The Sony had 111 features, and they were the same price. No question. I wanted those two extra features. So I bought the Sony. And I got it home and unpacked it, and there was the manual. And then it turns out that my wife figured out how to set the clock. This is when you had to do that, had to do it manually. And I have a PhD in engineering, and so my wife figured out how to set the clock. Now, how many functions do you think I actually used on that VCR.
I rewind, record.
If I'm really adventuresome, fast forward. And if I'm really adventuresome, I do the record. Yeah. So, yeah, maybe 4, 5 of the 111 features I had there. That's what you call creeping featureism. This is what Samsung does. And so it works, but people rarely use it in the end. Has to do with marketing. And the acceptance of a lot of technology has to do with marketing. And I remember when I was working for Procter & Gamble, I was just a new employee, but they gave us this orientation, this company orientation. So we went to the marketing department, the advertising department, and they were giving us their presentation. And they were talking about clothes washing detergents. That this was one of the products that Procter & Gamble sells, about Tide or something like that. And I said, hey guys, those commercials you put on the TV are the dumbest things I've ever seen. You have this person who brings these towels out, and they put them on the thing and washed with brand X. And they bring out the ones washed with Tide, they're much brighter and things like that. And I said, come on. I mean, that's an insult to the intelligence. And he said, we know. But we tried the intellectual approach. We told them the ingredients are one this, how they work, the chemical formulations, and how it does the. Those people didn't care. They just knew that lady, when she pulled that stuff out of her washing machine, they were whiter than the other ones. That's all they cared about. And then they started playing these gimmicks. They started putting these little color crystals in the soap. And those little color crystals released all this kind of stuff, And gosh, you look at the soap and you said, that's great soap. It's got all those little crystals in it and things like that. It's going to make my soap. They didn't do a thing. All they were doing is just put something in so people would buy it. Yeah. So that's the problem. I don't care what kind of technology you have. But here's the other thing that happens, though. They said, this is what these guys said, all we need to do is get them to buy it one time. After that, it's how good the product is. And so that's what advertising is to get the person to buy it. And if you buy one, you buy one iPhone, high probability you're going to buy another one, because it works and because it's good. Although I'm not too happy with what they've done to the latest iteration on the user interface with it. It's sort of gone minimalist, weird, and but that's what happens. Now, look at what's happened with these watch things. Now they talk to your phone, right? And where's that going to lead? Is that a gimmick? Does that have legs? Boy, you don't really know until after you see a while, because people don't wear watches anymore. You guys wear watches? Huh? Yeah, but see the watch I'm wearing? Yeah.
It's a watch, isn't it? It's a watch.
All right. Why am I wearing a Mickey Mouse watch? Is it to tell time?
No, it's your grandkids.
It has to do with a fashion statement I'm making. Talks about me. Doesn't have anything to do with telling time. As a matter of fact, you guys don't even have a watch because you have that. And it's amazing how this and now things become. Why do people put different cases on their phones? Doesn't make the phone work any better. It's individualizing. It's a statement. What happens ultimately is these become fashion statements. And this is, I think, what's going to happen here. This is all going to have to do with what kind of statement you're trying to make. Because is your life going to be any better because you're wearing this thing? Because you have something that communicates with your phone, it has a camera built into it? Don't know. Jury out on that. But again, you try out things and see if they'll sell.
I don't like the idea of speaking to my watch in a public situation.
Mm. Yeah, yeah.
People are.
But I tell you, the world's going to go crazy for a while over these watch things. You're going to see that in the next couple of years. You're going to see a lot of these things emerging.
They're trying to reinvent the watch by having it as a notification system for your phone, as well as what's that thing called? Steps.
Fitbit kind of stuff. Yeah, they'll be putting all kinds of physiological measurements in it, and that's what's happening with this new stuff. But this is cool. Have you guys know about the Dash? This is really cool. So these earbuds you put in, all right? So it's your MP3 player. That's it. MP3 player. It also sends a signal to your eardrum and measures the blood flow in the eardrum. It also has accelerometers in it and knows how you're walking and running and things like that, and at the same time measuring the blood flow in your eardrum, which is so thin that there's a lot of vasculature that you can image in there, and on and on and on and on. This is so cool. I don't know if anybody will ever buy it, ever use it, but you know, the idea is pretty neat. The idea is you have this wireless in-ear headphone. It's a Bluetooth. It's a Bluetooth headset, an MP3 player. It's so you can use it for your telephone. You can interact with the telephone. You talk with it and things like that. Fitness tracker, heart rate monitor, things like that. Starting at $179 on Kickstarter.
500. Oh, that's.
Okay. Kickstarter. We're going to talk about Kickstarter later on, right? You know what Kickstarter is, yeah. So it's a great system, this Kickstarter stuff and Indiegogo and so forth. Anyhow, if you invest $500 in Kickstarter, you get this, and it's basically what it is, ordering ahead of time before a thing is produced, and you're taking some risk there, but. So it does distance, speed, steps, you know, all this kind of stuff. Turns, airtime, G-forces. Oh, by the way, the reason you can do all of that, why can you do all of that now in these little things? Well, what is the technology? Where did technology come from? They started building all those things in here. And the phones, the flux gates, all of the accelerometers, 60-degree accelerometers, and so what's happening is they're taking that technology that's mass produced and just reconfiguring it a little bit and putting in this little earbud. Well, anyhow, I think it's so cool. You can even do it while you're swimming. Yeah. Then there's the fin. You guys heard of the fin? It's so cool. I mean, you've seen the skin put thing where you have the band around here, and then you use your hand just to input things. Yeah, but that's a little more difficult to do. This thing is just something that fits around a finger or around your thumb, and you just basically tap your different fingers like this. You have all these control inputs. And it's really going to be good for head-mounted displays. Because one of the problems with head-mounted displays, like the Oculus Rift, you can't see the outside world. You can't use a keyboard and things like that. But if you have this little controller, you can do this. And it can be intuitive on the way you do it, and the way you type and input and things like that. So the fin is a cute little device. Now, here's another thing for the Oculus Rift. Again, how do you put your whole body into it? Now, we were doing this years ago with a data suit, but This has sensors built in so that you now have a whole body input that you can put in these virtual worlds for gaming. Prio VR. This has not been built yet, but it's on the drawing boards. And then the I button. The I button is like a little button, you know, and what it does is let you locate all your devices. This is where you have a technology. You had to create a technology to solve the problems that technology caused before. So, you know, so you can locate all your devices, and also you can control them, turn them on and off, and things like that. This with the little I button.
Is it available for Android?
Yeah, Android, Apple, and Windows. Yeah, this is cool. This is a biometric device. So it turns out that everybody has their own unique, basically EKG, heartbeat. So you put your hand on this, and this becomes an entry thing for your car or for your computer or something like that, or a door. So you basically put your finger on this that recognizes your finger, your pulse rate, things like that, so you can enter into things. And it also tells time, you know. Ninja blocks. Have you guys heard of the Ninja blocks? Raspberry Pi kind of stuff, where you have all these different blocks you can build together to control things in your home. And you go to this website and you'll find out what to do in the ninjablocks.com. OBD link. You guys know about the OBD? Turns out all the cars built from whenever, 2006 or something like that, has this data block thing. You know, that's the way they do the analysis of all the sensors, things like that, how the car's working and things like that. It also has, you know, all the controls are coming through here. And so when you go to your garage to work on your car, they put in this analyzer, and then they analyze what's going on with your car. Well, this basically does it on your iPhone. So you plug in this block into your car, and now you can operate everything in your car with your iPhone. Even start it, stop it, change the temperature, all this kind of stuff. Yeah. So the OBD block, OBD link. This is pretty cool, actually. Pretty cool idea.
Guys, you can go in there and just grab the door and
Yeah, I have one of those, you know, that you lock it, unlock it, and you just carry something around in your pocket. Yeah. All right, here's your assignment for tomorrow. I want you to come up with a gadget. A hypothetical gadget. It needs to be a brilliant human interface gadget. And I want you to tell me, what problem does it solve? Who will use it? What would you have to do to make it happen? And what I'd like for you to do is make up a couple of PowerPoint slides or whatever that describe it, and send it to me, and we'll go over it in class tomorrow.
We need to come up with a sketch of it.
Yeah, that'd be good if you could. Doesn't have to be, we're not talking about artistic stuff, you know. This is something you're going to do on the fly, sort of like you did here. And but it's the main thing you want to talk about. What is it supposed to do? The problems does it solve? And who will use it? Okay?
That what would you have to do to make it happen question? Is that like how far the technology will
Yeah, I mean, what kind of technology would you have to make it happen? Some of it you can use off the shelf, some of it you may have to develop. Right. You might, for example, need to build a special chip that does something. You know, or I mean, it doesn't need to, I don't want it too outlandish. I mean, it's just something that, you know, could be, with a little work, a practical device. And the whole idea is it needs to solve a problem. So you need to think about the problems out there that just observing around you. And it doesn't have to be a high-tech thing either. I mean, if you can figure out a way to keep concrete from cracking, you'll be a gazillionaire. Think about that. Concrete tracks, all concrete tracks. I don't care how much rebar you put in it. It's okay. Any questions about that or about what went on today? You okay, Robin? All right.
Slides on system, the main system.
Sorry, the slides?
Slides, yeah, the slides.
These, I'll get Adrian to post them. Yeah, I'll give them to Adrian so he can do that. I'm not in the system yet, in the Learn system. I was last year, but I'm not in it now, so I'll have to. And Christoph is gone, so I'll get him to post these things for you, and then also the others you'll have. Okay, well, good. I hope you enjoyed today. It was sort of probably very general. We didn't get into any specific designs yet, but yeah, good. All right. Well, have a good rest of the day. Everybody squared away with your digs and with your computers here. Everything's going. Yeah. And your project, when you're doing your project, have some fun with it. But don't make it too big. You're not trying to win the Nobel Prize with your project. You don't want to make it doable. And projects tend to be way too large in scope. You know, and there's all this narrowing as you go. But you want to be simple and straightforward, and something that can be, helpful.
I guess you can always expand on it if you have time.
Yeah.
Awesome.
Good. Okay, guys.
Oh. I remember a few years ago, started